Hello and welcome back everyone to yet another lesson in Python programming. In today's lesson, we're going to work with yet another very popular library. This library is known as Pandas, and the Pandas library is quite useful when we want to structure our datasets. With that said, let's have a look at the objectives for today's lesson. Now, today's lesson is going to be quite brief. First, we'll take a moment to discuss the Pandas library, then we'll move on to exploring the applications, and finally, as always, we'll have a practical demonstration. Let's start off by defining the Pandas library. The Pandas library is a library used for working with large and small datasets, which can be used to carry out the data analysis process. It's also used for data manipulation techniques, which is quite popular in the field of data science. Pandas is a really useful library, especially when you want to provide structure to your datasets. Here are some of the most commonly used applications of the Pandas library. The first is to build robust data frames. It also provides readable data structures that look very similar to SQL tables or SQL database tables. Pandas allows us to organize very complex data into a meaningful way. And lastly, it's compatible with other data science libraries, which we'll have a look at in a second. Now, let's take a look at a code snippet. Notice that in this code snippet, we've also imported NumPy. And as I mentioned before, we can use Pandas as an integration tool with other data science libraries. In the first two lines of code, we first import the NumPy library. We also import the Pandas library. Next, we create a simple array using NumPy. Then we create a data frame using Pandas with column names, and after which we print the result out. Wonderful. Now it's that part of the lesson where we once again dive into a practical demonstration. So without further ado, let's dive right in. Much like in all the other previous lessons where we had to install the library first, we have to do exactly the same thing for Pandas. So in my command line tool over here, I'm simply going to run pip install pandas. And as always, I already have this installed, so you'll notice that the requirement has already been satisfied. I'll close this down. I'll begin my script by importing the NumPy's library. So import NumPy as np, and then I'll import pandas as pd. Great. So maybe we should also just increase the text size over here. Wonderful. Now I'm going to recreate the example that we actually saw in the slides, and that is because we didn't see the output, but I think this is important so that you at least understand how data frames work. So I'll create a variable called array over here. I'll set this equal to np dot array, and then I'll simply copy and paste an array that I've already created just for the sake of time. Remember, we are using NumPy over here to create this array object. And then on a new line, I'll create a variable called df for data frame. I'll set this equal to pd dot data frame, and now I need to provide a couple of arguments. So I'll open this up. The first one is to pass in the array. The next is simply just to change the properties of the columns or the column names. So I'll say x, and then I'll create one for y as well. And lastly, I'll create one for z. Great. Now, the first thing I need to do before I pass these column names through is I need to create an array object over here. So I need to open up square braces first, and within that square braces, I can pass in the column names. And this is what our syntax should look like. Then finally over here, I'll simply just print the df or the data frame object. And if I run this now, notice that this looks very similar to a table. One could even argue very similar to an Excel spreadsheet or even a SQL database table. We have rows over here. We also have columns running down. And you'll notice that by default, a data frame will always be associated with row numbers when using Pandas. So in column X, we have a value of 2, 12, and 4. In column Y, we have values 11, 4, and 14. And lastly, column Z, we have 100 right through. And I would argue that this looks a lot more structured and organized when compared to an array like this. Excellent. Now let's do one more example where we extract data from an external file using Pandas as well as Matplotlib so that we can visualize our data. We're going to replicate the example we had in our previous lesson where we compared the price of Bitcoin and gold over a 13-year period from 2010 up until 2023. But the approach that we're going to take here is we're going to extract the data from a CSV file so that we can basically generate this chart. But first, let's take a moment to explore the file structure to see what that looks like. Notice that in the project folder that I just created for the specific project, I have my main.py, I have my .idea folder, but I also have the CSV file called BTC_gold_price. If I open this up, this is what this looks like. Within one single column over here, we have the year, Bitcoin, and gold as the strings which represent the column names. And just below that, we've got a couple of rows. And within this row, for example, we have the year 2010 separated by a comma. Very, very important. This is how CSV files work. We've got the price of Bitcoin over here, and then we have another comma, and then we've got the price of gold. Likewise, for 2015, we have exactly the same thing. We've got the year, which maps over to the year over here. We've got the price of Bitcoin, which maps over to the Bitcoin column. And lastly, we have the price of gold, which maps over to the gold column. And that's basically what our CSV file looks like. So I'll keep this open for the time being. And now we can crack on with the rest of our script. Now back here in my IDE, I'm simply going to erase all of the existing code. And then I'll import Pandas again. Import Pandas as PD. Great. And then I also want to import Matplotlib, and I'll use the shorthand over here, pyplot, as PLT. Excellent. So the first thing I'm going to do is create a data frame, and I'm going to use Pandas to achieve this. So I'll create a variable called df, set this equal to PD, which is pandas, .read underscore CSV, and now I need to pass in the name of the file. Also notice that my file exists within the exact same folder as my main.py. That's very, very important. And then over here, I'll simply print the shape of my data frame. So df.shape, and then let's see what we get. So if I run this now, you'll see I have a data frame with 14 rows and 3 columns. Excellent. So what if we wanted to find out more information about our data frame? Well, there's a couple of things we could do. I'll run another print statement over here, and I'll do df.head. I'll use the head function over here. And if I run this code now, you'll notice that I have a description, or more of a detailed description of my data. So I've got the year, I've got the name Bitcoin, and I've got gold in the columns which we've already discussed. And then I have the rows. However, notice that not all of the information is being displayed over here simply because we are using the .head function, and that just gives you a brief indication of what your data structure looks like. Now let's take this one step further. I'm going to print df.describe. This is the describe function, and this is going to describe our data from a statistical point of view. So if I run this now, notice that I have the count, I have access to the mean of the Bitcoin value, the gold value, and so on. I also have the standard deviation as well as the min and the max value, including the quartiles. So this can be very, very useful if you want a statistical overview, at least the basics of your data. Then lastly over here, I'll call df.info just so that we can get a detailed description of what the data looks like from a technical point of view. So we can already see over here that the object is a data frame. We've got 3 columns. None of them are null, which means we don't have any missing data. And we can see that we've got integers and floats as data types for the various columns. Great. So one last thing, let's actually display our chart. So I'll call df.setIndex, and I'm going to set the index for year over here, and then I'll simply just do plot. And on a new line, I'll actually display the actual graphs. So plt.show. And now if I run this code, you'll notice that I've got an identical chart to the one we had previously. The only difference is that our labels are here in the corner of our chart, but the trend is basically identical. Now, I would argue from my point of view at least that this approach to generating the exact same chart is a lot more user-friendly on the eyes when compared to our previous example. And we can simply tell by looking at the amount of code required for our previous example where we used hard-coded values. In this example over here, we simply used pandas and matplotlib with just these few lines of code to do exactly the same thing. However, the requirement was that we needed to store that data inside of a CSV file. And that is it for today's lesson. In today's lesson, we learned how to use multiple data science libraries in Python, especially the popular ones such as Pandas, Matplotlib, and NumPy for integration so that we can visualize our data. So I really hope that you found this practical demonstration useful. In our upcoming lessons, we are going to be working with additional libraries. So for all of that and more, I'll see you soon. Cheers.